disconnected.
Hello student, first of all, happy Teachers Day. Today I will teach very important topic in mechanics, in kinematics, that is relative motion. When you apply the equation of relative motion, problem solving becomes very easy in case of kinematics, okay? In case of relative motion, major problem deals with the river water, rainfall problem, wind problem, aeroplane problem, and road transport problems, okay? So let's start. Let's understand the meaning of the relative motion and how do we apply in the numerical problem that we will see here, okay? So let's start. Relative motion means motion of an object with respect to another moving object. Motion of an object with respect to another moving object, that is studied under relative motion. Dear student, if we write VAB, what does it mean? This we read as relative velocity of A with respect to B. Here B is the observer. This is relative velocity of A with respect to B. Dear student, in this case B is the observer and A is the object. When we study relative motion, we study object motion in the frame of observer. When we study relative motion, we study object motion in the frame of observer. In the frame of observer, observer always remains at rest. In the frame of observer, observer always remains at rest. Okay. So, dear student, when we write VAB, this is velocity of A with respect to B means what? This we write as velocity of A with respect to common reference frame, and usually common reference frame is ground, minus velocity of B with respect to ground. In a very similar way, we write acceleration of A with respect to B equal to acceleration of A with respect to ground minus acceleration of B with respect to ground. Acceleration of A with respect to B equal to acceleration of A with respect to ground minus acceleration of B with respect to ground. Now let's see how to apply these equations in solving, in making problems easy in kinematics, okay? Problem solving becomes easier when we use relative motion concept. That's why we are studying relative motion, okay? This is case 1. Dear student, what happens? What happens when two objects move in the same direction? Okay, when two objects move in the same direction, what happens in case of relative motion? Let's see here. If this is object A and this is another object B, if object A in ground frame is moving with velocity v1 and object B in ground frame is moving with velocity v2, then in the frame, this is ground frame, dear student, in the frame of B, in B frame, what happens? relative velocity of A with respect to B will become V1 minus V2. This becomes 0. So dear student, how this came? See here. Velocity of A with respect to B equal to velocity of A with respect to ground minus velocity of B with respect to ground. So dear student, velocity of A with respect to ground B equal to V1 minus V2. This is the magnitude. When two objects move in the same direction, magnitude of relative velocity is the difference of velocity of the two objects. Okay. This is how we apply the concept of relative motion. Now, if you want to solve and if you want to apply this equation in solving numerical problem, you will see numerical problem becomes very easy. Let's see one problem. Dear student, if this is car A moving with velocity 20 meter per second, and this is another car B moving in the same direction with velocity 10 meter per second, and the separation between two cars is 100 meter. We have to find the time when car A will overtake the car B. We have to find the time when car A will overtake the car B. So dear student, if car A has to overtake car B, definitely the relative displacement of car A with respect to B must be 100 meter. For overtaking car B by car A, the relative displacement of car A with respect to B should be 100 meter. Now let us apply the concept. Relative displacement of A with respect to B equal to velocity of A with respect to B into time interval. So dear student, relative displacement of A with respect to B is 100 meter. Since both the cars are moving in the same direction, relative magnitude of relative velocity is 20 minus 10, this is 10 and this is the time. Let us cancel 0, 0, this is the 10 second is the time. In time interval of 10 seconds, the car A will overtake the car B, okay. What happens when two cars move in opposite direction? The magnitude of relative velocity will become VA plus VB, okay. Let us see another case. When two cars are moving in opposite direction, see here. If this is car A, this is moving with velocity 20 meter per second, and this is car B, this is moving with velocity 10 meter per second. And let us assume the separation between two cars is 100 meter. Then we have to determine the time when two cars will cross each other. We have to determine the time when two cars will cross each other. Determine, dear student, that two cars will cross each other when both the cars will travel a distance of 100 meter. So let us apply concept of relative motion. Displacement of A with respect to B equal to velocity of A with respect to B into time interval. Dear student, what is displacement of A with respect to B? This is 100 meter. What is magnitude of relative velocity of A with respect to B? This is 30. This is time interval. Let us cancel 0, 0 on both the sides. So we are getting time equal to 10 upon 3 seconds. This is the time when the two cars will cross each other. This is the time when the two cars will cross each other. Okay. Dear student, now let's see the river water problem, river crossing problem. Okay. River crossing problem. Dear student, let us see the river water or water velocity is VRG. This is velocity of river with respect to ground, or this is called flow velocity, or this is stream velocity. Let us assume the width of the river is L. Dear student, let us assume that the swimmer or the boat is moving with velocity VBR by making angle theta with river width direction. Now, dear student, we will be calculating the time to cross the river and also we will calculate the drift. Okay, what is drift? Drift is the horizontal displacement of boat, or drift is the horizontal displacement of boat along direction of flow of river. Okay. So, dear student, only component of boat along direction of width of the river will help in crossing the river. Okay. So, river crossing time in this case, the component of velocity of boat with in width direction is VBR cos theta, and this component will be VBR sin theta. So, dear student, what is river crossing time? This is L upon VBR cos theta. This is river crossing time. Okay, and what is drift? Drift is X. This is VRG minus VBR sin theta. This is net velocity in X direction multiplied by river crossing time. This is L upon VBR cos theta. This is what? This is drift. And dear student, what is displacement? Displacement of the boat or swimmer is what? This is L square plus X square under root. Now we will be looking for the particular cases when river is to be crossed in minimum time and when river is to be crossed along shortest distance. Now you can see when river is to be crossed in minimum time at the given value of L and VBR, the river crossing time will be minimum when cos theta will be maximum. And when cos theta will be maximum, its maximum value is 1. So theta should be equal to 0 degree. So dear student, if anyone wants to cross the river in minimum time, means the boat should be moved in a direction perpendicular to the direction of river flow. Okay. Now, if you want to cross the river along shortest path will come when VBR sin theta should be equal to VRG. Then only boat will be moving in the direction of river width. Okay. So we will be looking in both the cases separately. Okay. River crossing along shortest time, river crossing along shortest path. Okay. So let's see river crossing in minimum time. River crossing in minimum time. Dear student, as I told you, to cross the river in minimum time, the boat is to be sailed in a direction perpendicular to the direction of river flow. This should be the direction of VBR, okay? And this is direction of VRG river flow. So dear student, what will happen? VBR is not having any component in the river flow direction. So river crossing time will be minimum in this case. Dear student, in this situation, the time taken to cross the river is minimum and that is equal to L upon VBR. And what is drift in this case? Drift is VRG into L upon VBR. This is drift. And what is displacement? Displacement of boat or river is L square plus X square under root. This is more than L. So what you are observing? During river crossing in minimum time, the path length is not minimum, it is more than minimum. It is more than minimum. Okay. Now we will see the case. Now we will see the case for river crossing along shortest path. Okay. River crossing along shortest path. Dear student, the river will be crossed along shortest path only when there will not be any net velocity along direction of flow of river. Okay, then only river will be crossed along shortest path. So now let's visualize the case. Suppose this is river and this is the velocity of boat in a river, and this is river flowing with velocity Vr at angle theta. Now we can see this is the component of velocity of boat along river width, and this is VBR sin theta. So to cross the river along shortest path, this VBR sin theta should be equal to VRG. VBR sin theta equal to VRG. So dear student, to cross the river along shortest path, sin theta should be equal to VRG upon VBR. And we know value of sin theta always remains less than 1. Okay. So velocity of river with respect to ground should always be less than velocity of boat with respect to river. River, if you want to have zero drift, okay, otherwise zero drift will not come, though minimum drift can come. Now in this situation, river crossing time will be how much? VBR cos theta. If you convert this value of cos theta from this sin theta, you will find this result. This is VBR square minus VRG square. This is the time. Okay. So what you observe? To cross the river along shortest path, when path is minimum, time is not minimum. This you can see here. This time is what? This time is more than L upon VBR. So what you observe? When time to cross the river is minimum, path is not minimum. When path is minimum, time is not minimum. Okay, you understood. So dear student, this is how we solve the problem of the rivers. Okay. Now let's see the case of the rainfall problem. Okay. Rainfall problem. Dear student, here is some terminology. Let us assume this is velocity of rain and direction of rain. This is velocity of rain with respect to ground. And this is velocity of man with respect to ground. Now, if we calculate VRM, this is velocity of rain with respect to man. This indicates what? Velocity of rain with respect to man indicates the direction of motion of rain as appeared to man. Velocity of rain with respect to man indicates the direction of motion of rain as appeared by man. Okay. This is relative velocity of rain with respect to man. And this is what? In physical sense, this is the direction from which rain appears to come to man. And dear student, VRM can be written as VR minus VM. Okay, so we can write VR plus minus VM. If you draw the diagram, this is VR, this is minus VM, this is VRM. So VRM, magnitude of VRM is what? This is VR square plus VM square. This is magnitude of VRM. Okay. This is what? This is magnitude of VRM. Now umbrella is to be held in a direction opposite to VRM, means VMR. Umbrella is to be held in a direction of VMR. Okay. So dear student, this is the direction of holding of umbrella in order to protect men from rain. This is VMR. If this angle is theta, so theta is how much? This was VR, this was minus VM. This was VRM, this is VMR. So dear student, if this is theta, this is theta, so tan theta is what? Tan theta is what? VR upon VM. So theta is what? Tan inverse VR upon VM. This is the direction in which umbrella is to be held in order to protect oneself from the effect of rain. Okay. So dear student, this was in brief the concept of relative motion. In the next lecture, we will see the problems of relative motion. Thank you very much.